Welcome to the Easy Chemistry channel, and today we are going to be studying separation techniques. So the first separation technique is simple distillation. In simple distillation we can do two things. First thing is the separation of solvent from a solute. Okay, so previously what we used to do was that in a mixture of water and salt, what we used to do was that we would just heat this whole mixture up, and this water used to get evaporated and we were just left with salt. But this time around we don't need the salt, we need the water. So for that method we use simple distillation. Okay, so another important use of simple distillation is in the separation of two liquids. Alright, so the liquids that you want to separate should have, now this is the condition for this, the liquids that you want to separate, they should have at least a difference in their boiling points of 20 degrees centigrade. If they have this difference, okay, in their boiling points, then they are okay for simple distillation. So an example of this is the water and alcohol. So water has a boiling point of 100 degrees centigrade, and alcohol has a boiling point of around 78 degrees centigrade. So there is a clear difference of over 2. Alright, over 20 degrees centigrade. So we can use simple distillation to separate these two. Okay, now how is this whole process done? We are going to be making a diagram to clear this whole thing up. So this is how we do it. So first of all, we have a round bottom flask. A round bottom flask should look like this. Alright, and this round bottom flask is, by the way, covered by something known as a bung. Alright, and we have a thermometer as well. Which we already have inserted into this thing, and there is this distillation tube over here. Okay, and then over here there is a beaker or a conical flask which we use to collect the liquid that we want. Okay, so this is, by the way, the collector. Okay, so let's suppose we have mixed two liquids. Let's say it's water and alcohol, and we have this thermometer attached. And by the way, there is one more addition of an equipment, and it's known as a condenser. Some people call it a water jacket. So condenser is something which looks like this. Okay, now, so with the condenser we have a water inlet over here. Okay, so this is the place where the water goes in, and this is the place where the water goes out. Now this water initially is cold, so it's cold water in, and over here it becomes warm. Why does it become warm? We're going to understand that later on. Okay, now so what happens is, first of all we heat this thing. So the liquid which has a lower boiling point, that liquid has its molecules gain a certain amount of energy, and they move up and enter this place, which is the condenser. I think I should label it. Oh, this is, by the way, a distillation tube, so I'll just call it a tube. Okay, so through this tube, that liquid which has a lower boiling point, it moves up through this tube and is collected over here. So by the way, that liquid which moves up is in the form of gas. Now how does it turn from a gas into a liquid as it moves through this place? It's all because of this cold water that is going in. Alright, this cold water is going in, and it basically is surrounding this whole tube and providing it a cold environment and cooling it down in the process, cooling it so that it can become a liquid and be collected here. Now while you are doing all this, you have to monitor this thing, which is the thermometer. You have to monitor the thermometer. So the thermometer is going to tell you that right now the temperature is 78 degrees centigrade. Okay, so it means that all these molecules that are coming up, they are all the molecules of alcohol, because alcohol has a boiling point of 78 degrees centigrade. And as you are going to be monitoring this thermometer, the moment the thermometer hits 100 degrees centigrade mark, you are immediately going to remove this thing. Okay, and instead of this, you are going to place another beaker so that this liquid is then collected in that other beaker, which would be obviously water, because all the alcohol was already collected in the first method. In the first collection we got all the alcohol collected, and now we will get all the water collected. So this is how we are going to separate these two, and this is simple distillation. Now let's move towards the fractional distillation. So fractional distillation. By the way, there is not much difference between the fractional and simple distillation apart from a fractionating column. So I'm going to be drawing the same round bottom flask. All right, but there is going to be a fractionating column. So this long thing is a column. Now what purpose does it serve? We are going to soon find out. So again, it's covered with a bung. There is a thermometer inside. Okay, and there is obviously an opening. This is the distillation tube. Okay, and just like simple distillation, it's also covered with a condenser. All right, so water in and water out. by the way, cold water in and hot or warm water out. Okay, and here we are going to collect whatever liquid this is. Okay, so what happens is, in this fractional distillation we have a fractionating column, and this is, by the way, this extended length, this thing is the fractionating column. Fractionating column has small glass beads. Okay, they have glass beads. Now what happens is, because this fractional distillation is used for separation of liquids, and by the way, it's precise enough and it can separate liquids which have close boiling points, so it can easily separate those liquids which have closer boiling points. So let's suppose it has 3 liquids, A, B and C. So A has the lowest boiling point, C has the highest boiling point. So when you are heating this thing up, because this has A as a lower boiling point, the molecules of A are going to evaporate, convert into a gas and enter this fractionating column. So I'm just going to label it fractionating column. Fractionating column. So this A molecules are going to go up. Now obviously, because you're heating this whole thing up, you're not just heating the molecules of A. It is very possible that some molecules of B gain enough energy that they, along with A, they also escape the surface of the liquid and move up. Same can be the case for C as well. Some molecules of C might get more energy, enough energy to escape the surface of the liquid and go up. So as they move up and as they proceed up through the fractionating column, what is going to happen is that the molecules of A are going to escape all the way up and get through the distillation tube, while the molecules of B are going to go up, and because this upper portion of the fractionating column is not hot enough, they're going to collide with the beads and they're going to fall back. Okay, they're going to fall back. Same is going to happen with C as well, because C, its boiling point has not yet reached. So as you move up the fractionating column, the temperature drops, and so the molecules of C drop as well. Alright, so what we are going to get is, we are only going to get the molecules of A delivered right through this, and they'll be collected here. And because you have to, in this whole process, you have to look at this thermometer as well. So as you look at the thermometer, you have to notice that, okay, so now the boiling point of this A has passed. So now the boiling point of B is about to reach. So as it is about to reach, you should remove this beaker, and after some time place another beaker instead of this, which should be collecting B, since this was for A. And then the same case should be for collection of C as well. So this is how this fractional distillation is different from simple distillation. So it has the fractionating column. Alright, so the fractionating column basically makes the biggest difference. So what it does is that it basically doesn't allow any other molecules to pass through, except for those molecules whose boiling point has already been reached. So those molecules can only pass through, the others are left behind. While no such thing happens over here, you cannot be very sure that you have collected the exact molecules of one liquid. So there is a possibility that there are minute, very less quantity of alcohols also present in this water, and water also present in alcohol. So this was it for today. So tomorrow we are going to be learning about chromatography, RF values and everything. So this was it for today, and goodbye. Take care of yourselves.